So we sketched sine, and now I want to sketch the derivative. So let's take a look at a few critical points here. Let's start here at 0. Is our slope positive or negative there? Positive. So we know that for our derivative graph, we're going to have a point that's up here someplace. Now we don't necessarily know exactly what the slope is at that point, but we know it's positive at least. Okay, let's go here next. What is your slope at that point? 0. Okay, so then I can put a point here at 0 then.
Oh, it would just be a cosine.
All right, let's go to this point now. Is your slope positive, negative, or 0?
Negative.
It's negative, so we know it's somewhere down here. And then at this point, positive, negative, or 0? It's 0, so...
Oh my gosh.
And then out here, what's my slope? Positive. And so it would end up there. Now if I sketch in what the graph is kind of looking like at this, I'm seeing a graph that actually looks somewhat familiar here.
Oh god.
And in fact, we can use the graphs of this to actually come up with a rule. If f of x equals sine of x, then what does f prime of x equal? In other words, this blue graph is the graph of what function?
Cosine.
Yep, it's cosine.
Why is it cosine? Oh wait, I know why.
Now, having seen then, graphically speaking, kind of reasoning our way through what the derivative of sine is, we can do the same kind of thing to try to figure out what the derivative of cosine would be. And no, it's not just sine. So, approach it the same way. So on a separate graphing grid, sketch cosine, and then sketch its derivative so we can kind of see what should it look like. All right, so we've graphed cosine. Now we need to graph its derivative, or at least sketch its derivative. So again, I'm going to go point by point. So here at the start, my slope is 0. So I'm going to start there at 0. Then my slope here, notice, is negative, so I'm going to put it down the negatives. And then we're at 0, a positive, and then 0. And so if we sketch the curve through it, this is what we're looking at. Now, I said it's not sine. This is not the graph of sine, but it is closely related. Sine, of course, would start by going up, and then it would go down like that.
Wow.
It's been flipped upside down.
It's a reflection.
Therefore, it is negative sine of x.
Inverse sine of x.
Having seen those rules, we can now formalize them. These need to be added onto your derivative sheet. The derivative rule sheet that you already have going for your notes. These are the first 2 entries. We're going to be making 4 more later, but we'll save those for later. We'll do that in the next unit, like after break. But right now, just make sure that you write down these 2 and then leave yourself room for 4 more. So to find the derivative of this function, we first need to kind of look at the structure of what we're starting with here. Notice we got the 2 pi times the cosine. Will I need to use product rule here?
Yes.
No. Because 2
2
pi
is a number.
is a constant. And remember, anytime you're multiplying by a constant, you can just use the constant multiple rule, which is just a fancy name for multiply the derivative of the other function by whatever your constant is. So I know my answer for my derivative, so f prime of x, it's going to have 2 pi in the answer. And then the derivative of cosine. We just saw that's negative sine, right? Now, I definitely don't want to write it like this, right? That looks like minus sine. We don't want to do that. So instead, make it negative 2 pi sine of x. All right, so now taking a look at this derivative, again, you got to look at what you're starting with and plan ahead a little bit. In this case, will I need to use product rule?
Yes.
Yes, we will, because both of those are functions. And so I'm going to end up using product rule then. So f prime of x is going to equal, so I'm going to do original times derivative. So that's going to be the original e to the x times the derivative of sine, which is cosine. So we have e to the x cosine of x plus, now we do derivative times original. So derivative of e to the x, of course, is just e to the x. And then that's times the original sine of x.
Leave it like that, right?
Now, looking at it, we don't have to do anything else with it. If you wanted to factor out the e to the x, you could, but you don't have to. You can go ahead and just leave it like this, and that's perfectly fine. And so for this one, to find our derivative, at first it looks like something we cannot do, because right now it looks like we have a function divided by a function. And while there is a rule for that, we haven't learned it. But you don't actually need it for this one, because I can actually just rewrite this into a product. Because really I have pi cosine of x times x to the power of what?
-1?
Negative 1, yeah. By writing it like that, we now can use product rule. So from there, go ahead and do so.